everyone, in today's video I'm going to be talking about U-substitution. So U-sub is a method of integration that helps you integrate an integral of the form f of x times f prime of x dx. So initially this might not make a lot of sense to you, which is why we're going to go straight to an example to help you understand it a little better. So say I have the integral of 2x times the square root of 1 plus x squared dx. Right? So I look at this integral, and I think of all the integration techniques I've been introduced to so far, and I don't really know what to do with that, right? Because I can't use power rule on it. I can't really expand or simplify that square root function, so I'm going to try to make a substitution. So I see I have this big expression, 1 plus x squared, under my square root. So I'm going to call u, which is my new variable that I'm subbing in, 1 plus x squared. So I'm defining u as 1 plus x squared. So if I want to use that substitution and put that u into my original integral, I need to convert all of my x terms in the original integral to be in terms of u. So in order to do that, I need to find du, because that's the only way I can integrate that. So du, I can find that by just differentiating my expression for u in terms of x. So 1 plus x squared, the derivative is just 2x dx. Okay, now I go back to my question, my original question. I see I have a 2x dx right there. And look, I just found that du is actually equal to 2x dx. So I can replace this 2x dx in the question with just du. And also, the square root of 1 plus x squared, I can just replace that with the square root of u. So let's go ahead and do that. So I'm left with the square root of u. And instead of 2x dx, I'm writing du. Great. Now I know how to integrate this, right? Because I just have u to the 1/2 du. Right? Now I just use power rule. I add 1 to the power to get u to the 3/2 all over 3/2 plus my constant of integration. Right, now let's simplifying a little further. I have 2/3 u to the 3/2 plus c. Okay, I'm done integrating, but this is not my final answer, right? Because my question was given to me in terms of x's. So I want to convert my u back to x's. So instead of u, I'm going to write 1 plus x squared. So I have 2/3, 1 plus x squared to the 3/2 plus my constant of integration, c. And that's it. One important thing to note is that u sub is actually the opposite of using chain rule for differentiation. So what that means is that if I take this answer that I just got and I differentiate it using chain rule, right, because I have this inner function and I have the outer function of 3/2, I can go back to the original question or my original integral, the expression in my integral. Okay, let's do another example, but this time we'll use bounds on our integral. So I go from 1 to e to the 4 of 1 over x square root natural log of x dx. Alright, again, I look at this, it looks kind of nasty. I have a square root of natural log of x, and I don't really know what to do with that. So let's try making a substitution, right? So if I say u equals natural log of x, I know that if I find du, which is 1 over x dx, the 1 over x dx takes care of this part of my integral, right? So instead of this 1 over x dx, I can write du, and I'm just left with 1 over the square root of natural log of x, which is just 1 over the square root of u. So let's go ahead and do that. So I have integral of 1 over square root, and instead of natural log, we're writing u. And instead of all of this 1 over x dx, we're writing du. Okay. Now here's the tricky part, right? I cannot write 1 and e to the 4 as my bounds for this integral, right? Because going back to my question, these bounds are actually in terms of x. So I can't have an integral that whose contents are in terms of u and bounds are in terms of x. Like that's not how it works. Right? So I'm gonna erase that. And let's go ahead and find our lower and upper bounds in terms of u. So when x is equal to 1, what is u equal to? So x equals 1. We know u equals natural log of x. U is equal to the natural log of 1, which is just 0. And then let's take our upper bound. When x equals e to the 4th, u is equal to the natural log of e to the 4th, which is just 4. Right? And now we have our lower and upper bounds in terms of u. So I have u equals 0 to u equals 4, which is perfect. Now all I need to do is integrate and then use my fundamental theorem of calculus to simplify. So I'm left with the integral from 0 to 4 of u to the negative 1/2 du. Okay, I use power rule, so I have u to the negative 1/2 plus 1, which is just 1/2, divided by 1/2, evaluated between 0 and 4. Okay, simplify that further. I have 2u to the 1/2 integrated between 0, or evaluated between 0 and 4. And now I just plug in my upper bound. I get 2 times 4 to the 1/2 minus 2 times my lower bound, 0 to the 1/2, which is just 2 times, now 4 to the 1/2 is just the square root of 4, which is 2, minus 2 times 0 is just 0. So my final answer is 4. Now, one other important thing to note is that U-sub doesn't work every single time. You need to make sure that you're choosing the right expression for u, such that your other x terms in your original integral are taken care of when you find du. In other words, you need to make sure that you have no x terms remaining when you get to the point where you're actually subbing in u into your integral. Well, I hope that helped, and thank you for watching.